Today we are going to learn a new topic from the unit Nonmetals of class 9. The topic is chlorine. We all know that chlorine is an element of 17 group. Fluorine, chlorine, bromine, iodine, astatine are elements of 17 group. Now today we are going to learn about chlorine. Atomic number of chlorine is 17 and its mass number is 35. First of all, we discuss about some basic facts about chlorine. The element chlorine was discovered by Carl William Scheele, but it was identified as an element by Humphrey Davy. The term chlorine comes from the word chloros, which means greenish yellow, because chlorine is greenish yellow in color. We are familiar with the compound bleaching powder which are used as disinfectant. The main component of bleaching powder is chlorine. We told that chlorine is an element of 17 group. It is very highly reactive. So, chlorine does not exist in free state in nature. What are the basic facts about chlorine? Chlorine was discovered by Carl William Scheele, but it was identified as an element by Humphrey Davy. It derived from the word chloros, which means greenish yellow. It's a major component of bleaching powder. Because of high reactivity of chlorine, it is not seen in nature in the free state. Then we will discuss about some important compounds of chlorine. Some important compounds of chlorine are hydrogen chloride, then sodium chloride, that is common salts NaCl, and then potassium chloride. Then we will discuss about the preparation of chlorine gas. The arrangement and apparatus used for the preparation of chlorine gas is shown in this figure. The apparatus used are round base flask, thistle funnel, conical flask, delivery tube and a gas jar. And the chemical used are potassium permanganate, concentrated sulfuric acid, concentrated hydrochloric acid. So we will discuss how we can prepare chlorine. First of all, we take potassium permanganate in a round base flask. Then we add concentrated HCl to it using a thistle funnel. By the reaction of potassium permanganate with the concentrated hydrochloric acid, we get chlorine gas along with potassium chloride, manganese chloride and water. This chlorine gas then passed through delivery tube to a conical flask filled with water. This is done in order to remove the hydrogen chloride vapor comes along with chlorine gas. Then it is passed through sulfuric acid. It is because sulfuric acid absorbs the water vapor. Finally, we get dry chlorine gas and it is collected in an open gas jar because the density of chlorine is higher than that of air. Then how we prepare chlorine gas? Add concentrated HCl to potassium permanganate taken in a round base flask in order to remove the traces of hydrogen chloride vapors that come out of with chlorine. Chlorine gas passes through water. Chlorine gas is then passed through concentrated sulfuric acid in order to remove water, as sulfuric acid can absorb water vapor in the chlorine gas. Equation for the preparation of chlorine is shown. 2 KMnO4 plus 16 HCl gives 2 KCl plus 2 MnCl2 plus 8 H2O plus 5 Cl2. Finally, we get chlorine gas at the gas jar. Okay. Then we will discuss about the qualities of chlorine gas. We already discussed that chlorine, the word comes from chloros, which means greenish yellow. That means the color of chlorine is greenish yellow. You all are familiar with the smell of bleaching powder. It has a pungent smell. It's the smell of chlorine. The smell is pungent smell. In the preparation of chlorine gas, we use an open gas jar because the density of chlorine is higher than that of air. What are the qualities of chlorine gas? Color is greenish yellow, smell is pungent smell, and density is denser than air. We discussed that chlorine is an important element in bleaching powder. Now we will discuss the bleaching action of chlorine. Chlorine gas has a capacity to decolorize wet object. This means bleaching activity of chlorine takes place only in the presence of moisture. That means chlorine, the bleaching activity occurs only in presence of moisture. Then we will discuss in details the chemistry of bleaching. It can also be asked as questions like chlorine gas has a capacity to decolorize only wet objects. Why? Or otherwise, bleaching activity of chlorine is an oxidation reaction. Why? So we will discuss about the chemistry of bleaching. We earlier said that chlorine has only the capacity to decolorize wet object. That is, it act only in presence of moisture. So Initially, the chlorine gas reacts with the water vapor to form hydrochloric acid and hypochlorous acid. Hypochlorous acid is represented by HOCl. This hypochlorous acid is an unstable product, so it dissociates to form hydrochloric acid and nascent oxygen. Nascent oxygen is represented by O in a square bracket. This is an oxidizing agent which oxidizes the colored substance to colorless. This is the bleaching activity of fluorine. Once more, chlorine reacts in moisture to form hydrochloric acid and hypochlorous acid. Hypochlorous acid thus formed is unstable and hence decomposes to form hydrochloric acid and nascent oxygen. The equation is represented by Cl2 plus H2O gives HCl plus HOCl. That means hydrochloric acid plus hypochlorous acid. Hypochlorous acid, that is HOCl, dissociates to form hydrochloric acid plus nascent oxygen. This is the bleaching activity of chlorine. Next, we will discuss about uses of chlorine. We already seen that it is used for bleaching purpose, to remove stain from clothes, to purify water, to prepare bleaching powder, and to prepare pesticides. We all said that chlorine is the main component in bleaching powder. Then we will discuss how bleaching powder can be formed. Bleaching powder can be prepared by passing dry chlorine gas over slaked lime. That means calcium hydroxide. Dry chlorine gas reacts with the calcium hydroxide to form bleaching powder. That is 2CaOH twice plus 2Cl2 gives CaOCl twice plus CaCl2 plus 2H2O. That means CaCl2 is calcium hypochlorite. That calcium hypochlorite is called a bleaching powder. Right. Bleaching powder prepared by passing dry chlorine gas through calcium hydroxide. This calcium hypochlorite is formed, which is known as bleaching powder. The next question is, bleaching powder is a disinfectant substantiate. We know that bleaching powder is a good source of chlorine. When this bleaching powder reacts with water, it liberates chlorine. We already know that chlorine is a disinfectant. So, bleaching powder is also a disinfectant. Next, we will discuss about identifications of chlorides. In order to identify a salt as a chloride, first of all we take that chloride solution or salt solution in a test tube. Then we add silver nitrate solution to it. Then we get a white curdy precipitate. To that white curdy precipitate, we add ammonium hydroxide. Then the curdy precipitate dissolves. How we can identify? When silver nitrate solution is added to a given salt solution, if a white curdy precipitate soluble in ammonium hydroxide solution is formed, presence of chloride salt can be confirmed. We will learn in details by watching a video about this identification of chlorides. So, what we seen in the video, when silver nitrate solution is added to the salt solution, we get white curdy precipitate. This white curdy precipitate dissolves when we add ammonium hydroxide to it. The equation for identifications of sodium chloride solution is given below. The equation is NaCl plus AgNO3 gives AgCl plus NaNO3. We seen that a white curdy precipitate while adding silver nitrate. This is due to the presence of silver chloride, that means AgCl. When NaCl and AgNO3 reacts with each other, AgCl and sodium nitrate is formed. This silver chloride is the causes of white curdy precipitate. Hope you all understand. Next, we will go to the next section and the last portion of this portion. That means double decomposition reaction. In the above equation, we seen that sodium chloride reacts with silver nitrate to form silver chloride and sodium nitrate. The equation is NaCl plus AgNO3 gives AgCl plus NaNO3. Here, AgCl is formed by interchanging the ions of sodium chloride and silver nitrate. That means Cl ion along with sodium in sodium chloride reacts with silver ion in silver nitrate to form AgCl. Similarly, nitrate ion in silver nitrate reacts with sodium ion in sodium chloride to form NaNO3. Likewise, when two compounds combine together each other, when the products are formed by interchanging their ions, then the reaction is called double decomposition reaction. What is double decomposition reaction? Double decomposition is a reaction in which two compounds, when reacts with each other, interchange their ions to form two new compounds. When two compounds combine together, they interchange their ions and form new products. For example, NaCl plus AgNO3 gives AgCl plus NaNO3. H2SO4 plus BaCl2 gives 2HCl plus BaSO4. Okay. What we learned today? First we discussed about some basic facts about chlorine. That means chlorine was discovered by William Scheele, but it was identified as element by Humphrey Davy. It comes from the word chloros, which means greenish yellow. It's a main component of bleaching powder. Because of the high reactivity of chlorine, it is not seen in nature in the free state. Some important compounds of chlorine are hydrogen chloride, sodium chloride and potassium chloride. Then preparation of chlorine. First of all, we take potassium permanganate in a round base flask. Then it add a concentrated hydrochloric acid to it using a thistle funnel. Then it pass through water in order to remove hydrogen chloride vapors. Then pass through sulfuric acid to remove water vapor. Finally, we collect it in an open gas jar because its density is higher than that of air. Qualities of chlorine gases are color is greenish yellow, smell is pungent smell and density is denser than air. Bleaching action of chlorine occurs only in presence of moisture. Then chemistry of bleaching. First of all, chlorine reacts with the water to form hydrochloric acid and hypochlorous acid. This hypochlorous acid dissociates to form hydrochloric acid and nascent oxygen. This nascent oxygen oxidizes colored subject into colorless. Then uses of chlorine for bleaching purpose: to prepare pesticide, to remove stain from cloth, to purify water and to prepare bleaching powder. Then preparation of bleaching powder. Bleaching powder can be prepared by passing dry chlorine gas over slacked lime, means calcium hydroxide. Then by the reactions of calcium hydroxide with the chlorine gas, calcium hypochlorite is formed. This calcium hypochlorite is called bleaching powder. Bleaching powder is a disinfectant substantiate. While reacting bleaching powder with water, it liberates chlorine gas. Chlorine gas is a disinfectant, so bleaching powder is also a disinfectant. Then identifications of chlorine. How we can identify chlorides? First of all, we take the salt solution in a test tube. Then we add silver nitrate solution. A white curdy precipitate is formed. To this we add ammonia hydroxide solution. Then the white curdy precipitate is dissolved. Some examples are given. Sodium chloride plus AgNO3 gives AgCl plus NaNO3. KCl plus AgNO3 gives AgCl plus KNO3. Here the white curdy precipitate is due to the presence of silver chloride. Then finally, double decomposition reaction. Double decomposition is a reaction in which two compounds, when reacts with each other, interchange their ions to form new two compounds. For example, sodium chloride plus AgNO3 gives AgCl plus NaNO3. H2SO4 plus BaCl2 gives 2HCl plus BaSO4. Hope you all understand. Thank you.